So again, what we were doing was we were factoring out greatest common factors for this stuff. And that's all this question is here. So it says the area of a rectangle is that expression. It says the width is equal to the GCF, which is the greatest common factor. And it says what could the dimensions of the rectangle be? So you look at your answers and decide which one of those things out front there can you definitely divide all three terms by, and that'll give you your answer. So which one do you think it is? All right, Chloe votes for B. Any other thoughts on this one? Okay, so I agree that we can divide 12, 18, and 6 by 3. That definitely works, right? So let's do that. Let's talk about that real quick. All right, so if I divide 12 by 3, I'm going to get 4, right? If I divide 18 by 3, well, actually it's negative 18, I will get negative 6, right? And if I divide 6 by 3, I'm going to get 2. Okay, so that works. So let's look at our numbers now. We've got 4, 6, and 2. They're all even numbers. If they're all even numbers, what can I also divide by? Yeah, so I can divide by 2. So that means I factored out a 3, and then I also factored out a 2. And then 3 times 2 is 6, right? So that means I can factor out a 6. So this was a good start, but we could do more to it. So I can factor out a 6. This doesn't have a 6 factored out, so we cross him off, right? Okay, so we're down to these two guys. Now the question is, if I divide all these guys by 6x, am I going to get 3 terms or 2 terms? I was trying to erase here. So if we divide everybody by 6x, so you can either do this one of two ways. You can either take 6x and divide it into this guy. Hang on, my pen's not working. Divide it into this guy and see which one of these you get, whether you get this or this, right? Or you can multiply here and see if you get this guy back. Okay, so if we multiply here, so if we look at A, as you mentioned, Chloe, you're only going to get 2 terms here, right? And down here, you'll get 3 terms, right? So 2 terms and 3 terms. Okay. So let's look at our original expression, or whatever you want to call it here, this guy. How many terms does he have? So he has 3 terms, so we probably need these guys to match up, right? So if we need them to match up, which answer is right? But remember, and you bring up a good point, Chloe, but remember this. So what we have here is if we have 6x for the last term, right? And we're pulling out a 6x, right? So that means divide by 6x. What does 6x over 6x equal? And this is where they're trying to trick you. Six x over 6x, what's that equal? Yeah, that's 1, right? So that's this guy right there. See how that works? But yeah, exactly. So you bring up a really good point, and I'm glad you did, because that's what happens to a lot of people, and that's why a lot of people miss this problem. You know, even if they get it to the point where it's like, okay, it's A or D, they think, well, the 6x cancels out. But remember, we're not taking 6x minus 6x, it's 6x divided by 6x. So that'll give you a 1. So then the bottom line is the answer to this guy is D. Okay? So that's actually a pretty good problem. That brings up a lot of different things that can happen here. You know, we explored most of that, so that was good. All right. All right, thank you, Chloe. That was good. All right, we're going to move on. So here's our new stuff, factoring trinomials. This is kind of a big deal. This is going to keep showing up for the rest of high school math. So we get this down now. It's going to save you a lot of trouble down the road. Okay, so factoring trinomials, we're going to start off, we're going to do like this little puzzle here. And it's called the diamond method. Okay. And I've seen these, like I've seen worksheets where they have like a baseball diamond and stuff like that. But basically think of it more of as a puzzle. And if you're good at this puzzle, you're going to be good at factoring. Okay. So if we start with just like playing like we're playing a game here, like playing a puzzle, right? Doing a puzzle. And then we will apply that either later today or next time to actual factoring of trinomials. Okay. But I've found in the past that, you know, even I had some students earlier in the semester in Algebra 2 that were having trouble factoring, and we played this little game here and it helped them out a lot. So I thought maybe we just lead off with this and show you how it works. Okay, so here's how the game works. Got a little rule set up here. Okay, so what we have here is we're going to have this diamond, and up here at the top, there's going to be a number. Okay, it's going to be a number right here. This is a product, so this means we have two numbers that multiply together to give us that number. So, for example, if the number was 6, we could have maybe 2 times 3, right? So here's your factors. So 2, factor 1 times factor 2. So 2 times 3 gives me 6. Okay, that's a possibility. Another possibility would be, hang on a second. What's another possibility besides 2 times 3? What's another way you can multiply numbers together and get 6? This one's usually so obvious that people forget about it. One times 6, perfect. So we got 1 times 6. Okay, so that works too. So there's two possible answers here, right? So the way we determine which one we want to use is based on this number here. So the factors, what we do is we multiply them together, and that gives us the top number. And then if we add them, it gives us the bottom number. So 6 times 1 is 6, right? But what if we added these guys together? What's 6 plus 1? Yeah. So if we had a 7 down here and a 6 up top, then the numbers we want is 1 and 6. So this one determines the possibilities, the factors, because there's only so many different ways you can multiply two numbers together to get a certain number, right? In this case, 6. We got two versions of it. We got 1 and 6, we got 2 and 3, right? Which determines how we determine which one we're going to use is based on the number at the bottom. So let's do this. Let's say, okay, so we know we have our possibilities. We got 1 and 6, we got 2 and 3, right? So what if our bottom number here, the number that we add together, is 5? Which set of numbers should we use? Should we use 2 and 3, or should we use 1 and 6? Yeah. So 2 times 3. Okay. So this one tells you how many different choices you have. In this case, we had 2 different choices, and this one narrows it down for you. Okay. So then what this really does when we get around to it, I'll give you a preview, and then we're going to practice some of these guys. So if you had x squared plus 5x plus 6, on our puzzle here, the 6 is going to be the guy upstairs. All right. So that's this guy. And the number in front of the x, the 5, is going to be that guy. Okay. And then we said, well, the answer to this one is 2 and 3. Okay. So the way we'd write that is we would write the whole idea of factoring is to get this thing down that we don't have to deal with an x squared. So this whole thing would become x plus 2 and x plus 3. And what that tells us is when we FOIL this out, when we multiply this guy back together, we will get what we started with. Okay. So that's the logic behind this. And then, like I said, if you want to check it, we can do that. Hang on, we'll do that. So we do x times x, that's x squared. We do x times 3, that's plus 3x. We do 2 times x, that's going to be plus 2x. And then 2 times 3 is plus 6. So we have an x squared term, we have a number term. So bring them down, we get x squared, we got plus 6. And then the two guys in the middle, we can put them together, right? 3x and 2x is going to be 5x. And notice that this is what we started with. But like I said, let's practice the puzzle and then we'll apply it to this stuff. Like I said, either later today or next time. Okay, so let's try a few of these. Let's get good at this. Okay, so our first one here, we've got two numbers that we want to put in here and here, right? And they have to multiply together and give you 24, but they have to add together the same two numbers and give you 10. So what's our numbers going to be here? What numbers are we going to put in here to finish off the diamond? Okay, well, 5 plus 5 does equal 10, right? But 5 times 5 is 25, isn't it? So those aren't going to be our guys. Our guys have to multiply together to give you 24. That's 25. Okay. Pretty good guess, but let's figure something else out here. Yeah, 6 times 4. Beautiful. All right. So then we go ahead, plug in our numbers. So we get 6 times 4. Now in this case, the order doesn't matter. I could say 4 and 6 or 6 and 4. Either way is good because 6 times 4 is 24. 6 plus 4 is 10. Boom. There you go. All right, how about the next one? This one, we multiply together and get 32, and adds together to give us 18. So again, the way to approach this is look at the possible factors of 32. What multiplies together and gives you 32, but now we need to add together and give us 18. Okay. As a rule of thumb, the bigger this number is here, the further apart these two guys are probably going to be. Like here, they're pretty close, 6 and 4, because 10 is quite a bit smaller than 24, right? Well, here 18 and 32, they're closer. So I'm expecting numbers that are further apart than we had in the first one. So, and like I said, you'll get the vibe for this as we keep practicing these. Okay. So what are some factors that you can multiply together and give you 32? Sometimes it helps just to list those out. Okay, 7 times 4 is 28. So what's something that gives us 32? Yeah, 8 times 4. Okay, good. So 8 times 4 gives you 32, right? So 8 times 4 gives you 32. Good. But now if I add them together, 8 plus 4, does that equal 18? No, it only equals 12, right? So we need numbers that are further apart. So we need this guy to be something bigger and this guy to be something smaller. So what's some other possibilities? So see how the game works? We figure out some numbers that multiply again and give us 32. Then we add them together and see if we get the number on the bottom. So what's some other numbers that multiply and give us 32? I'll get us started. So there's 1 times 32, right? But if we add those together, I guess it's 33, right? So that's too big. So does 2 go into 32? Yeah, because it's an even number, right? So we take 32 and divide by 2. If we're not sure of that, we can always use our calculator, right? So I go 32 divided by 2 is 16. So now the question is, if I add 16 plus 2, do I get 18? Yeah, so that's our boy, isn't it? And again, the order doesn't matter. I can put the 2 here and the 16 here. Order will matter a little bit when we start talking about negative signs, but for right now, we're good. Okay? So there we go. 2 times 16 is 32. 2 plus 16 is 18. That's our guy. All right, how about the next one? So this one wants two numbers that multiply together to give you 18 and add together to give you 9. This is like Sudoku before there was such a thing. So 6 times 3. Okay, 6 times 3 is 18, right? 6 plus 3 is 9. Boom. Somebody's getting good at this. Nice. So 6 times 3. Good. All right, let's move on. Here come the negative signs. All right, so here's the thing about these. If you have two numbers multiplied together and we get a negative answer, what sign does one of the numbers have to have? We're going to have two negatives, we're going to have two positives, we're going to have one of each. How's that going to work? Yeah, one of each. Good. So what that tells us is one of these guys in this particular setup has got to be negative, right? So we still want to figure out two numbers that multiply together and give us 36, but they add together to give us negative 5. But the thing is, one of them is going to be a negative number. Okay. So what's some numbers that multiply together and give us 36? Six and 6. Okay, let's try that. So what we're saying is 1 6 is going to have to be positive, and 1 6 is going to have to be negative, right? So 6 times negative 6 will give us minus 36. Good. But 6 minus 6 is going to give us 0. So if our bottom number was 0, these would be our guys. But our bottom number is negative 5. So these two guys can't be like the same number, like 6 times 6. So we need to talk about some other factors for this particular one. Okay? So 6 times 6, that one's out. What other factors do we have? So what the minus 5 is telling us is the factors have to be two numbers that are 5 units apart. So like if one was 5, the other would have to be 10. But obviously that's not right because 5 times 10 is 50, right? So we need two numbers that multiply together because 36, and then they're 5 apart. Well, 9 times 9 is 81. So that's not going to get us where we need to go. This is where those timetables are coming. So negative 9, okay. Let's try negative 9. All right, if this guy's negative 9, what's our other guy? So 9 times what gives you 36? So this is where a calculator might come in handy. Yeah, 9 times 4, good, because I was just going to say here, we could do this. We could say, well, I got 36 and I'm going to divide by 9, and I get 4. Good. So if I make this guy positive 4 times negative 9 is negative 36. Check, right? And then 4 minus 9 is minus 5. Bingo, that's our guys. So this one, it's going to be 4 and minus 9. Okay? Starting to get the hang of this a little bit, right? Okay, how about the next one? So this one, we've got a negative 20. So again, one guy's going to have to be negative, right? They multiply together and give you negative 20, but they add together and give you negative 8. So what's our possibilities here? Two and 10, okay? And which guy's going to be negative? I totally agree with you. Yeah. So if we put minus 10 here and 2 here, 2 times negative 10 is negative 20, and 2 minus 10 is minus 8. Bingo, got it. Nice. Okay, how about the next one? So again, same deal. If you see a negative here, you know one of these guys has to be negative. 3 and 5. Which one's negative? Okay, so the 5 is negative. 3 is positive. 3 times negative 5, negative 15. 3 minus 5, minus 2. Beautiful. Nice. And it's usually easier to work with when we have a little smaller number up top, right? Because there's less factors usually. Okay, good. All right, so we're going to look at some other possible scenarios here. So notice this guy. We've got the minus sign up top, right? But now, remember on this one, we had all negatives at the bottom. Now we got positives. Okay, so we're still going to say the same thing. Since it's minus 36, we're going to have a minus sign for one of them. So now these guys have to multiply together and give you negative 36, but they have to add together and give you positive 9. So notice over here, let's back up to this one real quick. Notice over here, when we were doing this and we had the negative number down here, the bigger number of our 2 was always the minus. So I'm thinking with this guy, the bigger of the 2 is going to be the plus, right? Okay. So you came up with 12 times 3. Beautiful. And again, the bigger number we're figuring is going to be plus this time, right? So plus 12 and minus 3, right? 12 times negative 3 is negative 36. 12 minus 3 is 9. Bam. Got it. Nice. How about the next one? Like I said, we do a lot of these because, like I said, if you get good at this game, that gets you good at factoring, that gets you good at math for the rest of high school, because it'll really help. Okay, so this one, you're thinking 10 times 2 is 20, right? Okay, and we said one of them's got to be negative, right? And we're saying in this case, the bigger number is going to be the positive. So we get 10 and minus 2, but 10 minus 2 isn't 1, is it? It's 8. So here's the thing. Think about this too. The number on the bottom, the smaller it is, the closer that number is to 0, the closer together your factors are going to be. So 2 and 10 were kind of far apart. We need two numbers that are kind of close together. 5 and 4. Beautiful. Good. So we do 5, and we'll make the 5 positive, right? And the 4 negative. So 5 times negative 4, negative 20. 5 minus 4, 1. Got it. Nice. So again, the bigger this number is on the bottom, the further apart your factors are going to be. So here, notice they were close together, 5 and 4. This number is kind of big, so they're kind of far apart, 12 and 3, right? So this one's 14. So again, they're going to be kind of far apart, right? And we're thinking one of them is going to be negative, obviously. All right. So what factor should we use this time? We have to multiply together and give us negative 15, but yet add together and give us 14. So what's our two numbers this time? $15 and 1. And we're going to keep the 15 positive, right? So 15 and 1. So 15 times negative 1, negative 15. 15 minus 1 is 14. Boom. Perfect. Good. All right, let's check out a few more. Okay, so we're going back to the top number is positive, right? But the bottom number is negative. All right, so we know that when you multiply two positive numbers together, you get a positive answer, right? What happens when you multiply two negatives together? What happens? Still positive, right? Good. So what we're thinking here is both our guys are going to be minuses. Okay? And again, we want two numbers that multiply together and give us positive 12, but then add together and give us minus 7. So what's our possibilities here? Four and 3. And again, since they're both minus, the order doesn't really matter, right? So minus 4 and minus 3. Minus 4 times minus 3 is positive 12. Minus 4 and minus 3 more is negative 7. Got it. Good. So when you see these guys and the top one is positive, but the bottom one is negative, then we know we have two minuses. So that's going to be the case in all of these guys, right? All right, how about this guy? Multiply together and give you 6, add together and give you 7. We know the negative sign's going to be out front. Well, 3 times 3 is 9. So I don't think that's our guy. I think you're adding those guys. Top guy you multiply. So two numbers that multiply and give us 6. Well, 6 times 2 is 12. I think you meant 6 times 1, right? Probably just a typo, huh? Yeah. Okay, so 6 times 1. Negative 6 times negative 1, positive 6. Negative 6 minus 1 more, negative 7. That's our guy. Good. Okay, how about the next one? So we need numbers that multiply together and give us 16 and add together and give us 8. Yeah. So minus 4 times minus 4. Good. So negative 4 times negative 4 gives you positive 16. And then minus 4 and minus 4 more is minus 8. Beautiful. Let's try a couple more and we'll call it. Okay, so this one, we have a negative at the top. So that means one of them has to be negative, right? and then our numbers add together and give us 0. So I think we kind of talked about one similar to this before. What's our guys? Yeah. -6, +6. Good. So -6 times 6 gives me -36. And 6 minus 6 gives me 0. Awesome. All right, this guy. So we've got they multiply together and give us 4, and add together and give us 4. So what's our two numbers here? And they're both positive, so I think we can leave everybody positive. We don't have to worry about any negative signs this time. Yeah. Perfect, right? 2 times 2 is 4, and 2 plus 2 is 4. Perfect. Good. All right, how about this guy? So this guy's -1, but they add together and give us 0. What are we going to get this time? Yeah, 1 and 1. And then since it's -1, one of these guys has to be negative. So that's our guys. Cool. Looks like you're getting the hang of this. We'll practice a few more of these next time, and then we will get into some actual factoring. But you do the exact same thing for factoring. Okay? All right, so I've already got attendance for you guys. So Chloe, I appreciate you playing along. And we'll stop the recording, and we'll see y'all next time.